Alright, let's talk about area, and specifically area between two curves. And we're going to go about this like a rectangle. So let me just take a rectangle from 1 to 2 and let's say that's 3. And I'm going to draw a rectangle here. And the height of that, say this is y equals 3 and this is y equals 0, will be the top function minus the bottom function is the height, which is 3, of all the rectangles. So no matter where you draw your rectangle, the height of those rectangles is always 3. So that's going to be the top function minus the bottom function. So if I just integrate 3, again, remember that's the height, and the dx represents the width, and our rectangles are along the x-axis between 0 and 2, and that's going to be 3x 0 to 2, which is 6. But we know the whole rectangle is height times the length, the area. So if this is 2 and this is 3, it's 3 times 2 is 6. So the point is you can just integrate to get the area between two regions. So just for this picture, suppose we have these two curves. This is f of x and g of x, and we're going between A and B. Then the area between the two curves is going to be the integral from A to B, and the height of one of the rectangles is going to be this right here is f, and this right here is g. The height's going to be f minus g, f of x minus g of x, because the function's measured from the graph to the x-axis. So again, when I have a function here, this is the function distance, or the y distance, the vertical distance. So the height of that rectangle is f of x minus g of x, or the top function minus the bottom function, dx, which is your width. Okay, if you're going the other way, if you take horizontal rectangles, suppose the functions go like that, and this is, say, h of y and j of y, and take your rectangles this way, and go from y equals c to y equal d, and this time the width of that rectangle is dy or delta y, say delta y is the width, so we're cutting up the y-axis. It's going to be from C to D. This distance is h, and this distance is j, so this is h minus j, h of y minus j of y, which is the right function in terms of y minus the left function in terms of y, dy. Alright, so let's just work a few examples. I have y equal 1/2 x, x equal 2, and the x-axis, let's graph this region. A half x goes like that. X equal 2 is here in the x-axis, so I'm dealing with this area here, the area between those two curves, and it's going to be, we're cutting up the x-axis, so we're going from 0 to 2. The top function is here, so it's 1/2 x. The bottom function is 0, so this is 0, this is the half x, So that height is top minus bottom dx. When I integrate that, that's going to be 1/4 x squared, because that's going to be x squared over 2, 0 to 2, which is going to be 1. Now, that's a triangle, so we can check it. The area of a triangle is 1/2 the base times the height. So 1/2 the base here is 2, and the height is 1. That height is 1, which is 1. So that checks. Area is 1. Okay, let's look at this example. You have to be careful sometimes. It's a line, and we're going from -1 to 1 and 0. And actually, let's set this up. The area between the two curves, I want the area now, so I'm not just going to integrate it. You can use some kind of symmetry here. Just integrate one of the triangles and multiply it by 2. So if I go from -1 to 0, you have to switch it. You're going the top minus the bottom. Here's the top, which is 0, and the bottom is 2x. So it's 0 minus 2x. And then you're going to go from 0 to 1. See, the top and the bottom switch, so that's why you have to do it separate. Whenever the top and bottom switch, the bottom is 0, so this is 2x minus 0. Okay, well, to integrate negative x, we set that up as -x squared from -1 to 0. The top is, again, 0, and the bottom is 2x. So when you integrate that, you get -x squared 0 to -1 to 0 plus x squared 0 to 1. When you integrate that, you get 1 plus 1, which gives you 2. Now you take that, and you take the area of the first rectangle. Okay, that's right here, and that's 1/2 the base times the height, which is the half 2 times 1, and that's 1. So the area of this triangle is 1, just using geometry. The area of this triangle is 1 because it's the same size, so that the area of the two triangles is 2. So that just checks that we can use geometry here because they're nice triangles. But you have to be careful, because if you just integrated from -1 to 1, 2x, you get 0 since 2x is odd. So since we're finding the area between the two curves, and we want the total area, we have to separate it out, because the top function changes when you move to the right. You get different tops and bottoms. So if you, like I said, if you just integrate it, you'd be 0, and that doesn't represent the area of those two triangles. You also have to have a positive answer when you do this. So those are two things to be aware of, that you may have to split up the integral, and you can use symmetry, but you always need a positive answer, since you're talking about area. So let's look at another example. I have x equal 1, y equal x squared, and y equals 0. That's what I'm bounded by. So it's going to look like this, this, so, no, this isn't x equal 1. X equal 1 is here. So I'm talking about that region. So I'm just going to set this up. I'm going to integrate from, I'm cutting up the x-axis because that's where the width of my rectangle is, 0 to 1. Top is x squared. The bottom is 0 dx. Okay, if I wanted this so let's say x equals 0, which is the y-axis, x squared, and y equal 1, then I want, there's my right. It's always important that you draw a rectangle. I think that'll help you decide what you're integrating. Here I'm cutting up, again, the x-axis, because that's where the width, if I have a dx here, which represents the width of the rectangle, then that's what I'm going to integrate on this x-axis. So I'm going from 0 to 1. These are x values. And the top function is 1, and the bottom function is x squared. See, the height of that rectangle is, that's 1. This is x squared, so this is 1 minus x squared from here to here. Top minus bottom, and that's how I would set that problem up. So that's a different area. All right. Well, what if it's not easy to see where they intersect? So, like if you have y equal x and y equal x squared, that's all they give you. So you have this parabola and you have the straight line, x and x squared. And I want this region in here, so I draw my rectangle like that. So first, what you really need to do in all these problems is find the intersection points. Now, if it's easy to see, then you don't have to do this, but we have to find out where we're integrating from. Like we're integrating from here to here, and we don't know that point, so we set the two equations equal, and that's going to give us x equals 0 and 1. So 0 and 1 is where we're going to integrate. So then you decide what is your top and bottom function. My top is x, and my bottom function is x squared. So I'm going to integrate 0 to 1, top minus bottom, dx. Now I could also do this problem this way and use y. Okay, this is dy. So everything, once you decide where the width of your rectangle is, that tells you that everything here has to be in terms of y. Okay, so this point right here happens to be 1, 1. If this is 1, then the y value is 1. Y is equal to x, so they're the same value. So I'm cutting up the y-axis this time from 0 to 1. And my right function is, if y is equal to x squared, then x is equal to the square root of y. So my right function minus my left function, okay, again, this is the square root of y. This is y, because x is equal to y. So it's right minus left. And y equals x, so x equals y. And you integrate that as you're going from 0 to 1. Again, I'm just going to set this up. Okay, let's try this one. X equals square root of y equals 1, and x equals negative y. So we have this right here. We have y equal 1, and we have this function turns into y equal x squared, so that's a parabola. So we're dealing with this area right here. If we use x's, then notice when we go top minus bottom, the bottom function changes, so we're going to have to split it up. We're going to have to go from here to here and here to here because they have different bottom functions. So I'm going to integrate. We got to find out where those intersect. That's where these two intersect, and that's going to be at y equal negative 1. When you solve that, you get negative x equals 1, or x equals negative 1. So this is negative 1. So we're going to go from negative 1 to 0. Here we're going to go, The top function is 1. The bottom function, the bottom of the rectangle, touches that line there, which is minus x dx. And again, I'm using axis because my width of my rectangle is delta x. Then I'm going to go from 0 to 1. This is 1. And my top is 1. Top function here is 1. And my bottom function here is x squared. And integrate that. Okay, so again, I'm just setting these up. This top minus bottom. If you don't want to break them up, though, then you can integrate in terms of y. And just use a rectangle that goes like that, because your left and your right function do not change when you do that. So in that case, you're going from y equals 0 to y equal 1 dy. The width is y, and the right function again has to be in terms of y. So if x is the square root of y, then the right function is square root of y. Everything has to be y's. And the left function is x equal negative y, so that's a negative y. And that one you don't have to split up, because no matter where you draw your rectangle, your right and your left function do not change. So you have to test it out, because previously, if you go up here, see where I draw my rectangle here, the bottom function is the line. But where I go over here, the bottom function is the parabola. So they switch. And that's what you would integrate to do that problem.